Okay. Your book mentioned this one. I think they mentioned it in lesson 3, but we'll do it right here. 3, 4, 5, special right triangle. Why is it special? Well, it's the first, what they call a Pythagorean triple. If you do, that a Pythagorean triple is integers that fall out of the Pythagoras theorem. So leg squared plus leg squared equals hypotenuse squared. Okay, so you got 4 squared equals 5 squared. Look, it works out. 9 plus 16 equals 25. Check, right? So this is, yeah, you can use it also to, all right, it's useful. Right now, we're just going to look at all the relationships within. So please pause this. And what is the sine of A? Cosine, tangent, cotangent, da-da-da-da. Okay. Okay. Here we go. Sine of A. Opposite over hypotenuse. Cosine of A. Adjacent over hypotenuse. Tangent of A. Opposite over adjacent. Cotangent. Adjacent over opposite. Secant. Hypotenuse over adjacent. Cosecant. Inverse of sine. Hypotenuse over opposite. Okay. Now, let's look at angle B. And we'll just write these in reverse order. So we're going to go sine of B. Sine, oh, I might be messing up here. Maybe I got this messed up here. I do. Never mind. We'll just write it down from the top, right? So pause this video, please, and do sine, cosine, tangent, cotangent, secant, cosecant of B. Okay, ready? Pause. Then I'll do them. Okay, here we go. Sine of B. We know, if we think about this, that the sine of B is opposite over, it's going to be the same as cosine of A. Cosine of B is going to be 3 over 5, right? And then these two will be reversed, okay? Tangent of B, 4 over 5, opposite over hypotenuse, the same thing as and the secant of B, 5 over 3, right? And cosecant. Okay, and these two are, all right, so we got that again. We got complementary angles. The sine and the cosine are this, you know, in cotangent and cotangent, and secant and cosecant. All right, hope that's clear as mud. Okay, let's look at, and let's get these angles. What is angle A and angle B? All right, do you remember how to do that? So the tangent, we'll just solve a couple of these down at the bottom. So if you remember how to do it, go ahead and give it your best shot now. Solve for angle A. What is angle A using the tangent? What's angle B, angle A, angle, and I don't know if I can't find that on my little old calculator. Okay, so please solve these 4 angles. Find angle B this way and this way, and angle A with this and this. Okay, and then I'll do it. Okay, here I go. Tangent of A, remember, is opposite over adjacent, 3/4. So, to solve for the angle, every operation in math has an inverse. Everything you can do in math, you can undo. So, I'll just write all this out here. Yes. Tangent inverse of tangent of A equals, I'm going to take whatever I do on one side, I have to do on the other. Tangent inverse of 3/4. So I'm inverse. I'm going backwards. I'm undoing the tangent. So then I'll have angle A. This is angle A, right? Just solving for angle A. I can put it in my calculator. I just have this little cheap Casio calculator. Hope you can read this just fine. All I do is I find my tangent button, and above it says tangent inverse. So shift tangent gives me tangent inverse, and then I just put that in there. 3 divided by 4 equals 36.86. So 36.7 degrees. I'm sorry, 36.9. Let's just go with 37 degrees. I think that's what your book says. So about 37, not exactly 37. 36.9 degrees. Okay. And let's just sine of B. Sine of B is opposite over hypotenuse. Sine of B is 4 over 5. Okay, so sine inverse of sine B. You don't have to always write this down, but I would at the beginning. This is algebra is what this is. You're using an inverse to solve an equation. So this is the same idea as algebra. So sine inverse of sine, those two operations cancel one another out. And I put this in my calculator. So I put in clear, shift, sine. So that gives me my sine inverse. I put in 4 divided by 5. 4 divided by 5 equals 53 point something, 0.1. So 53 degrees. All right. So, and if you add these two up, what do you get? 53 plus 37 better equal 90. Complementary angles. Okay, let's look at secant. So I would do, what is the secant of A? Secant of A, inverse of which one? Inverse of cosine. So secant of A is 5 over 4. Well, I don't have that button on my calculator. I don't have a secant. Maybe there's some way to find it, but I don't see it anywhere. So what I'm going to do is say, well, what's the inverse of secant? SEC, well, I'm going to go COS. I'm putting the C in. That's how I remember secant and cosine are inverse of one another. So the cosine of A is 4/5. Okay, so if it asks you to use, I don't know that it would ever, anyways, if you're stuck using cotangent, secant, or cosecant, well, use their inverse. That way you can find the exact answer on your calculator. So A equals cosine inverse of 4/5. Okay, let's see, shift, cosine inverse, 4 divided by 5 equals, great, 37 degrees again. A equals 37 degrees. All right, just checking out that all this works. And what's the cosine of B? Cosine of B, up here we had it at, why did I write 35? Whew. Guess I need to eat some breakfast and wake up. 3 divided by 5. Okay, clear, clear, clear. So cosine 3 over 5. So B equals cosine inverse 3/5. Shift cosine, cosine inverse 3 divided by 5 equals 53 degrees again. So there, this lesson 3, we did our trig ratios along with the relationship of complementary angles and how their sines and cosines are equal and why. And we did our special right triangles. 45, 45, 90, 30, 60, 90, and your 3, 4, 5. Okay. Have fun with all that.